Okay, here is our method for determining or calculating the area bounded between two functions. So suppose we're handed two functions, f and g, such that f is always bigger than g on some interval, a to b. Then this blue area, the shaded area here, in between these curves, is the definite integral from a to b of top minus bottom. You don't have to memorize anything fancy here. It's literally just big minus small. Imagine if I wanted this area. That area that I just shaded, that would be the integral from a to b of f of x dx. And what if I wanted to subtract out this area under g here? That would be the integral from a to b under or of g of x. Well, the integral is a linear operator. Because I have the same limits, I could combine this into one integral and we get this. That's all we're doing, is we're taking the area under f and subtracting off, because we didn't want to count this chunk here, subtracting off the area under g. So it's always top minus bottom. Okay, so here's a good example. I want the area bounded in between these two functions. So notice they didn't tell me my a and b. They didn't say start here and end here. They just said, figure it out. What's the region of integration here? I'm going to have to figure out here my a and my b based on where these two graphs intersect. So anytime somebody asks you find the area between two curves kind of problem, always draw it out, always algebraically figure out where those two graphs intersect, and then figure out the region you're trying to find. Figure out who's on top and who's on bottom. That's important. It's always top minus bottom. So the first thing we're going to do here is figure out where these two graphs intersect by setting them equal to each other. So set the functions equal. And like you can check the algebra here. We get x is -2 and 6. So that's -2, that's 6. So then we're going to do the definite integral from -2 to 6 of the top one, which in this case we called f, minus the bottom one. And then we got to be careful here, distribute that negative. And then like this is just a regular old definite integral. You should just be able to do that on your own. Okay. What if our two regions cross over each other a bunch? What if I have maybe a picture that looks like, and I want to find maybe here is A and here is B. And somebody tells me find the area between these two regions. Well, this is a weird question, because what they really mean is find all the positive areas. So we've got some regions, we'll call this guy, maybe that guy's F and this guy is G. We've got this region here where F is on top. F is bigger than G. Then we've got this region in here where G is the one on top. And then we're back to, say we're going back and forth. Now F is on top. Now G is on top. And now in this region, F is higher than G. So I think I was doing red for F on top. So all of this shaded area is what I would want to find. That's what this question's asking for. One way to make sure we're always counting all of our areas positive is take the absolute value, but doing an integral over an absolute value is really difficult. So the way we do this in practice is we find all these crossings, all these different X values here. So maybe I'll call this C, D, E, F. And we'll do each integral, making sure we write the one on top first. So if I were going to write this out, I will want the total area will be the integral from A to C, this red region, F minus G, plus the integral from C to D, that blue region there, and who's on top? Whoever's on top put first, G minus F. And so forth. Here, integral from D to E. F is the one on top in that region, so I want him first. And then in this blue region, G is the one on top. So that was from, these are my X values, from X equals E to X equals F in that. Maybe I shouldn't have used the letter F. Maybe let's not call that F. Let's call it H. Because F already means a function. So from E to H, we want G minus F. Because we want this to be a positive number, and G is always bigger than F in that region. So G minus F will always be positive. That's what we're doing in each of these. That's how we do the absolute value. We break it up into regions, and we always put the higher one first minus the lower one. And then finally, the integral from H to B of F minus G. So if we have one of these problems, we'll find every place they cross in between our starting and ending points, and we'll break our integral up into a bunch of different regions and make sure we always have the one on top first, which means we have to graph both the functions out, and we got to do a little bit of algebra. Okay. So here's an easy one. One guy's always on top of the other one. They don't tell me my X limits. I mean, I can look at the picture and see it's -2 to 2. But if they don't tell me my limits, I'm going to have to find those myself. The picture is already drawn for me because I copied this from the book. Let's find out what those intersections are. Maybe we'll call this Y1 and Y2. Where do those equal each other? When x squared minus 3 equals 1, that's x squared equals 4, or x is plus or minus 2. Right there. So I want the definite integral from -2 to 2, top minus bottom. The top one is 1 minus, and then parentheses. Don't forget your parentheses here. So I would distribute that negative there, get 1 minus x squared plus 3 dx. And then I would add my like terms together. I think that's 4 minus x squared dx. And now we do the definite integral. We'll get 4x minus x cubed over 3, evaluated from -2 to 2. So top minus bottom, plug in 2 for all my x's, minus, now plug in -2. And I know I could have done a lot of this in my head, but I want you to see where everything came from. So that's 8 minus 8/3. Minus, and then here I'm going to leave this in parentheses. I get a -8 plus an 8/3. And I got to be careful with my negative here. Distribute that negative. That's 8 minus 8/3. Plus another 8. Minus another 8/3. I think that's 16 minus 16/3. which I think is 32 over 3. Because that would be 48 over 3 minus 16. Okay. This one we're just going to set up. I'm not going to solve the whole thing because we get really nasty limits. But I want to find the shaded area here. I'm trying to find the area bounded between these two functions. I got to find all the intersections. So let's set, here we called them F and G. F equal to G. X cubed equals X squared minus plus X. Let's move everybody on one side. X cubed minus X squared minus X equals 0. Factor out an X. Okay, so X equals 0 is clearly one of the solutions. I mean, we can see that in the picture. Now I'm going to have to use quadratic formula to find the other two because that won't factor. So opposite of B plus or minus square root of B squared minus 4 times A times C all over twice A. I'm going to get 1 plus or minus square root of 5 over 2. So that's that point and this point, those X values. So then the area is going to be in this region, the orange one is on top. So that was 1 minus root 5 over 2 up to 0. That's this region here. And I want orange minus blue. X cubed minus, and then in parentheses. Make sure you have parentheses there. And then plus, now I'm going to go, now I'm doing this region here. Now the blue one's on top. We're going to write the same stuff, only these two guys are going to be swapped. And my region is going to be from 0 up to 1 plus root 5 all over 2. And now I'll have X squared plus X minus X cubed dx. And then I'm just going to dot this. You could work that out if you want. This is a problem from the book. You can just go to the book and find out what the solution is. I just don't want to have to plug in those nasty values. Okay, this one we're going to get much prettier answers. It's a similar problem, but we're going to get prettier answers. Okay, let's graph both of these. Always graph everybody. Your graph doesn't have to be perfect, but it should be relatively accurate. Here is y equals x cubed. X squared minus 2x. We could write as x times x minus 2. So there are my x-intercepts will be at 0, 0, and at 2, 0. And it's a quadratic. So we're going to get something that looks like this. And I want to go from -1 up to 1. So in this region, let me color code these guys. In this region, back here, the red one is on top. The parabola is the red one. He's on top from -1 to 0. And then from 0 to 1, in this region, the cubic is on top. All right, so we're going to have the area then will be the definite integral from -1 to 0, because that's where they cross at 0, of the parabola minus the cubic dx. Don't forget your dx. Higher minus lower. Plus, and then we're going to have in this region from 0 to 1, because why 1? Because that's what it told us. We're only going to 1 of the cubic minus the parabola. And I got to put this in parentheses or I'll get the wrong answer. Now, my recommendation is, like, yes, we have very similar looking stuff here. In fact, once I do this integral, I'm going to get exactly the opposite of what I get over here. My recommendation is there's so many negatives floating around in these problems. Just do these one at a time. Don't try to do it. Don't try to do too much in your head. Don't go, oh, well, whatever I get here at 0 is going to cancel out whatever I get here. Yeah, you're going to get some cancellation. Just take your time. Just do this one step at a time. So maybe we'll even write these separately. We'll call this definite integral number 1 so that we don't get overwhelmed. So that will be x cubed over 3 minus x squared minus x to the 4th over 4, evaluated from -1 to 0. So check my work there. You should believe that this is the antiderivative of that. Now we plug in top minus bottom. So if I plug in 0 everywhere, I'm going to, excuse me, get 0. Minus. Now let's plug in -1. I'm going to get -1/3 minus 1. -1 squared would be 1, and that minus is that minus. And then -1 to the 4th is also 1. So I'm going to have a -1/4. Let's clean all that up. And we better get a positive answer for both of these. If you get a negative answer, final answer for either of these, you've done goof somewhere. This better end up being a positive, and you can see it will be. So that will be negative. So let's make all these 12ths. That's -4/12 minus 12 over 12 minus 3 over 12. So that's 7, -19 over 12. And times that other negative right there, we get a positive answer. If you don't get a positive answer, you've done goofed. All right, now let's do integral number 2. See, do each of these separately. Yeah, you're going to have a lot of similar looking fractions. It's too easy to get messed up with your negatives. I'm going to go ahead and distribute that negative there. So doing the integral, we'll get x cubed over 3 minus, oh, no, I totally lied. We're going to get x to the 4th over 4 minus x cubed over 3 plus x squared, evaluated from 0 to 1. Plugging out 1 for everybody, I'm going to get 1/4 minus 1/3 plus 1 minus, and then when I plug in a 0 for everybody, I get 0. All right, so what do we got there? That's 3/12 minus 4/12 plus 12/12. So that'd be 15 minus 4. I think we get 11/12. So then total, 19 over 12 plus 11 over 12. I think we get 30 over 12. Or 10 over 6, 15 over 6. Let's see. What's the biggest thing that goes in there? 6? 5 halves? Okay, let's do one more. I'm just going to do all this in one video. All right, let's graph both of these guys out. Maybe we'll call this guy y1 and y2. y1 is a quadratic. He points up because my leading coefficient's positive, and he is shifted up 10. We're going to have something that kind of looks like this. That guy's a line, and his y-intercept is up here at 16, has a slope of 4. He's going to look something like that. And I want to go from -2 to 5. And I think, let's see, if we plug in -2 here, that would be -8 plus 16. This guy's still positive at that point. So I'm not back here. I'm like maybe right here, -2, because he's still positive, up to 5. Oh, we got to figure out, am I past the point where they cross each other or not? I need to figure out these two spots there, where they cross. So let's set them equal to each other. This is a quadratic equation we have here. We solve quadratics by getting everything on one side and factoring. Let's see, I think we'll get -6. Yeah, -4x, 10 minus 16 would be -6. I'd pull a 2 out of that. And then that factors. That's x minus 3, x plus 1. So they cross at x equals 3 and x equals -1. Okay, so that crossing spot right there at -1, that's one place they cross. The other one is over here at 3. I want my limits of integration, my outer bounds are going to be from -2 out to 5 out here somewhere. Let's draw that quadratic a little higher to show. So I'm going to have 3 different regions. Region number 1 right there, where the quadratic's on top. Region number 2, where the line's on top. And then region number 3 up here, where the quadratic's on top again. You're going to have a question just like this on test 4. This morning you had it. All right, so I want the integral. Let's call it number 1. That's the integral from -2 to 1. Remember, your limits are always your x values, your domain here, of top minus bottom, quadratic minus line. And don't forget your parentheses here. And don't forget your dx. I want to go ahead and write out all the integrals first, and then we'll do them. Integral 2 is from -1 to 3. That was -2 to -1. I dropped my negative there, right there. -2 to -1. -1 to 3. The line is on top. 4x plus 16 minus 2x squared plus 10. dx. And then region 3. It's going to look just like region 1. The parabola is on top. We're going to go from 3 to 5. So it's going to be exactly the same integrand. Okay, now let's work each of these out. We'll see if I can copy and paste this. All right. And like from this point on, it really is just doing 3 different integrals and adding them together. Remember, each one better be a positive answer or you've done goofed. So -2 to -1, 2x squared plus 10 minus 4x minus 16 dx. That's -2 to -1. 2x squared minus 4x minus 6 dx. Just adding like terms there. So I distributed that negative and then added like terms. All right, what do we get here? We get 2x cubed over 3 minus 2x squared. So I'm going to get 4x squared over 2. 4 over 2 is 2. Take your time and work this out on your own if you don't immediately see that. Minus 6x. The antiderivative of 6 is 6x. Evaluated from -2 to -1. All right, so we plug in top minus plugging in bottom. So plugging in a -1 there, -1 cubed is -1. I'm going to get -2/3. -1 squared is +1. And then -1 times -6 would be +6. Minus -2 cubed is -8. So -16 over 3. -2 squared is +4 times -2 will be -8. And -2 times -6 will be +12. And like, I don't know if there's a best way. Like maybe it's best to distribute the negative and kind of add like terms. Maybe it's best to do each one of these individually and then add them. Like for fun, I'm going to distribute this negative because maybe it'll end up being less arithmetic later. So distribute that negative. I have +16 over 3 +8 minus 12. Because now I can just add these two together. That'd be 14/3. And I can just add all my numbers. Let's say I'm going to have 14 minus 14. Those just all cancel. Okay, so that's region 1, 14 over 3. Now let's do region 2. I don't know if I'm going to be able to copy and paste this. Yeah, I think I can get it. All right, let's clean this guy up first. This would be -1 to 3, 4x plus 16 minus 2x squared minus 10 dx. I'm sure you can see there's a lot of places you could make a silly mistake in these. I hope I'm getting them right. Oh, here, let's put this in ascending order or descending order. -2x squared plus 4x plus 6 dx. I should get exactly the same thing I got before, only opposite now. So I have 2 minus 4 minus 6. Now I've got -2 plus 4 plus 6. Okay. So this will be -2x cubed over 3 plus 2x squared plus 6x, evaluated from -1 to 3. All right, so we plug in the top. -2/3 times 27. Plus 3 squared is 9, so I'll just do that. That's 18 plus another 18 there. I'm going to plug in the 3. Minus, in parentheses, plug in the -1. -1 cubed is -1, which will kill that negative. So this is a 2/3. -1 squared is just +1, so times 2. And then I think we'll get -6. All right, since I've already got thirds in there, I'm not going to cancel there. I'm going to call that -54 over 3 And I'm gonna add those 36. Let's see, that's -4 times a negative will be +4 and then -2/3. So I've distributed that negative. All right, so that's what, 40 minus 56/3. Which will be 120/3, multiplying top and bottom by 3 here, minus 56/3. Let me get my calculator out. And remember, like I'm just going to do 120 minus 56, but you could do, your calculator smart. I could do 40 minus 56/3, hit enter, and then I could go right here under math, into fraction, hit enter again. There we go, 64. So that 120 minus 56 is 64. So 64/3. We're almost done. By the way, if I do make any silly mistakes in any of this, I haven't worked this problem out yet. If I do make any silly mistakes, the first person to email me with a correction gets an extra credit point. Copy that. There we go. All right, region number 3. And then we'll just add all these together at the end. All right, what we got here? This will be the definite integral from 3 to 5 of 2x squared minus 4x. I feel like I may have copied something wrong. On that one. Hold on, let me check real quick. Something seems wrong. Oh, that's a 16 there. Yeah, I should get exactly the same integrand that I got on that first one, and I was not, because that's a 16. 10 minus 16 would be -6 here. Okay. Now, let's do it. It's there. So this would be 2x cubed over 3 minus 2x squared minus 6x evaluated from 3 to 5. Plug in the top. 5 cubed is 125, so 250/3. 5 squared is 25, so minus 50 minus 30. 5 times 6. Minus, in parentheses, 3 cubed is 27 times 2 is 54/3. That'd be 9 times 2, so 18, and then minus 18 there. Now, see, I remember when I first learned this, thinking, well, whatever I get when I plug in 3 here is going to be the same as when I plugged in 3 in this one, and those will cancel it. You'll see, look, they're not canceling out. See, these were plus 18, plus 18. And look what I'm going to get here. Plus, they're not canceling out because we swapped the order. So that's why you don't want to try to write all this out in one big, long formula or expression. Stuff's not going to cancel. They're actually, you're counting that part twice because that order's flip there. So it's so much better to just do these one at a time and just take your time. All right, what do we got here? 250/3 minus 80 minus 54/3 plus, because that'll be minus 36 times that minus plus 36. Okay, and again, I can just get my calculator out here and do this if I don't feel like adding all these fractions. So, and I can literally just type it the way it looks. Minus 80 minus 54 over 3. You just got to be careful, make sure you type everything right. And then go math into fraction, hit enter again. We get another 64 over 3. So total, I think we got 64 over 3 twice and 14 over 3. So that's 128, 130, 142 over 3. Let's check that. $142 over 3, which 3 does not go in there. I think we're done. All right, I'm going to pause and I'm going to check this answer. Okay, here's where I got the problem from. This is a great resource, by the way, Paul's online notes. Like you can see here, he's got it all nice and graphed out. Here's all his regions. And look, he got exactly what we got. That should make us happy. All right, that is a good place to stop.